Hello everyone, welcome back to our lesson. In this video we're gonna talk about the Pascal triangle and the binomial expansion. What I'm going to do right now is to show to you what is Pascal triangle. But always keep in the back of your mind that we should have to learn and know the binomial expansion. So just visualize a binomial. So it is a plus b raised to the second power. So we can do it through foil, right? But one thing is, the problem is, what if there is we engage into bigger power, so like a plus b raised to the power of 16 or 100. So there are so many processes how to get the answer. So let me fill our whole paper in solving that. So in this video we're gonna make it simpler through the Pascal triangle, but right now I will show to you what is a Pascal triangle. So here is the Pascal triangle. I'm gonna put Pascal triangle. So all we have to do is first is to put 1 in the top. So next is to have 1 at every edge. So like we are having our triangle, little triangle. So right at the left we have another 1. So and then 2. So how did we get the 2? So by looking at above numbers, so we have 1 and 1, we came up in 2. So and another 1. So just like we need to fill this out. So next one is another 1 at the edge. So 1 plus 2 equals 3. 2 plus 1 is 3. And then put another 1. So we just have to add. So how do we get 3? To add numbers above it. So next one is we put 1 at the edge. So 1 plus 3 is 4. So 3 plus 3, 6. 3 plus 1, 4. And put another 1. So we can do this if we want to. So how could we get 6? We should have to add 3 plus 3, which is above it. So we should not have to leave any spot. So it is like a mirror. So as we can see, so 3 and 3 is a mirror. 4 and 4 a mirror, and 1 and 1 mirror is just like a form of symmetry. So it has shown a mirror image. So next, what we're going to do now is to label it. So I'm pretty sure this is so very important for us to know about this. So I label it as row 0. So this is row 1. This is row 2. Row 3 and row 4. So right now we will need to understand it. We will have to label it because we will further know how important it was to know about the rows. So we will have to continue solving the expansion of binomial, or we should have to determine how to make our binomial expand. So we have a plus b raised to the power of 0. So we will always start with 0. So any number which could be raised into 0 is equal to 1. So the answer is 1. So a plus b raised to 1. So anything that it means that it raise means it multiply itself, so a plus b raised to 1, so itself, so a plus 1, a plus b. So next is to the second power, a plus b to the second power. So we'll know that a plus b times a plus b, so we're gonna have to do this. So we're going to have a distribution process, so we will have to distribute it. So a plus a times a is equals a squared. So what is the outside term is ab, the inside term is ab, the result 2ab plus b squared. So b times b is equal to b squared. So next is we have to determine the cube of a plus b. So we came up to a plus b times a plus b squared. So we all know that. Yeah, so we have to go, we have another 2, have to distribute it. So it results to a cube plus 3a squared b plus 3ab squared plus b cubed. Another thing that we should know is that we should have to take a look of the exponent. So in order for us to solve it more simpler, we should have to take a look of the exponent. So like for example, a plus b squared, so we should have to start it as a squared, so plus 2a. So yeah, we have to take a look with a squared. So a goes down, it goes down as the b goes up. So next, plus b squared, so a goes to 0, it is really eliminated, and then b goes up. So next one is a plus b cubed, so the result is a cubed. So we should have to start with a cubed, so plus a 3a squared. So as we know that a is decreasing, or it goes down as b goes up to 1, so from 0 to 1. So next is 3ab squared. So as we all know that a squared goes down again, so and b1 makes b2, so it is goes up, so and b, so yeah, a is eliminated, so b cubed, so b goes up. So we should have to take a look, so there should be the same process. So a goes up, a goes down, b goes up, a goes down, b goes up, and a goes down, 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 b goes up. So that's it. Another thing that we should notice about this is that a plus b squared, so this is squared, so a squared, so it does have a same exponent, so 2ab, so this is 1, this is 1, and this is 1, and it is resulting to 2 if we all add the exponent, so b squared, so it is the same. Another 3, the power of 3, so the result is a cubed 3a squared b, so b has 1 power, so it also resulted to 3, so this must be 3, 3, this 3, so a 1 plus 2, 3, and the last is, this must be 3 also. So the second thing around is that we should have to notice about this. So as we all know, we will compute it, so a squared, so as a goes down. The exponent goes down as b, which is goes up, and b goes up again. And then the a cube, so as a goes down, b goes up in power. So a goes down, b goes up, b goes up. Another thing that we noticed is that, for example, so this a plus b squared. So the result is a squared plus 2ab plus b squared. So I noticed that there is the same exponent as the power. So there, if the power here is 2, or it is risen by the second power, so there is the exponent also is the same. So a squared, so 2ab, so there is a 1 over here and 1 over here, resulted to 2 plus b squared, so it is the same. So another is a plus b raised to the power of 3, so the result is a cubed plus a squared b, so 2 plus 1 equals 3, so 3ab, so 1 plus 2 equals 3 plus b cubed, so and so on and so forth. So that's it. So right now, so I'm gonna make this table in order for you to understand these two concepts about the Pascal's triangle and the connection of the binomial expansion to it. So as we all solve this, so a plus b raised to the power of 0 equals to 1. So as we all know that it is similar to our table, the Pascal's triangle. So a plus b, we have an imaginary 1 here, 1a plus 1b. So it does have the same coefficient as row 1, a 1, 1. So next is a plus b raised to the power of 2 is equal to 1, 2, 1, 1, 2, 1. So we will just have to look for the coefficient. So a plus b raised to the power of 3, 1, 3, 3, 1, 1, 3, 3, 1, or the row 3. This is our row 3. So we should have to use this. So we should have to look for this. So next is row 4. So we have 1, 4, 6, 4, 1. There should be 1 here. So 1, 4, 6, 4, 1. So it goes the same with our binomial expansion. So right now we'll have to take another example in order for us to understand it very well. So we have x plus y times 4, so it is different. So but we will have to check if we are right, if we don't have to make this process. So we will just to look for the exponent or the increase and decrease of the power. So first thing to do is to put x first with the exponent of 4. So but I recommend to put Pascal triangle, the 4 power, which is the row 4. We should have to use this coefficient, Pascal triangle. So the 1, the 4, the 6, the 4, and the 1. So right now we'll have to solve it. So first we should have 1. So it is equal to x raised to the power of 4, of course. So next thing is to put 4. So we should have to use this because our power here is 4. It is risen by 4. So we have 4. So what happened next? When x is up, so it must be down. So 4x cubed, and our y, so there is no y over here, so or y is equivalent to 0, so y goes 1. There is 1 over there, so plus, but we don't need to put it. Next is 6. So as x goes down again, x squared, and y goes up, so it is y squared plus, should have to put plus over here, plus, next coefficient is 4. As x goes down again, x, and y goes up, y cubed plus what's the remaining? So x goes 0, so it is eliminated, so y 4, y the power of 4. So this is our answer. So this is now our answer. So x to the power of 4 plus 4 x cubed y plus 6x squared y squared plus 4x y cubed plus y raised to the power of 4, and this is the result. So now this how we expand the binomial using the Pascal triangle. So thanks for watching, and I hope you learn and enjoy. Thank you so much.